Okay, what do we got here?
It looks like gas within the root zone of this tree, this linden tree.
That linden.
I think that one was also a linden that just never really made it.
It is a linden. It is a linden.
The honey
and the
locust.
buds are still alive. Honey locust.
And then this sugar maple.
Private sugar maple.
It's centered right here. So I would take a high read, and what I would do is I would move it right over the drill holes.
Yeah.
I would take the CGI reads out of it first.
Yeah, that's what I was thinking. CGI.
Take the CGI reads.
Yeah.
And don't bang bar them, because that'll give you an unnatural flow.
Right.
So you just drop the CGI into these, take the readings, and then do the box on top of them. Get the extent of the readings. Actually, the flame unit is maybe even better. Or the Picaro going around and on the top with the extension tube.
Yeah.
Because this is all gas in here.
Yeah. So yeah, I was thinking the CGI or the Picaro doing what you said here, but also then, you know, basically taking it to the furthest extent and just finding the boundary where it gets up, you know, above a couple percent maybe, and then basically quantifying the extent and then going back and using the chamber.
Yeah.
Does that sound like a reasonable approach? And then also back in here doing the same thing.
See if there's anything.
Is the chamber the upside down gas thing?
Yeah.
Or the trash bin?
We call it the FGEC.
Fugitive Gas Emissions Chamber.
Yeah. Which is basically fortuitous use of trash barrels, kiddie pools, and sandbox lids. So
whatever is appropriate.
Right. So for the manhole covers, the sandbox lid works just perfectly.
So this is what it's sniffing now?
Right now, yeah. It's, you know, got a little couple second delay.
Around 11, and under 2 would be a background normal reading?
Right.
This went up to almost 50.
Yeah, it was over 50.
60. 55 right here. And I'm not going to stop. I'm just going to go over this slow and see what happens here. I'll keep it around this speed.
We put this over, you know, some portion of the leak, whether it's on soil or, you know, or this pavement. And this is sealed to the ground, the best we can do, okay? So we've created a kind of a closed chamber here. And what we're doing is we're both pulling the air from the chamber, okay, as the methane is seeping into that headspace, into that volume. We're pulling it into the machine and measuring it, and we're simultaneously taking the exhaust from the machine and returning it to the chamber, okay? It's a recirculating system, and the reason that we want to recirculate it is so that we're not pulling air out and creating this vacuum condition, this artificial vacuum condition that will just suck methane out of the ground in an artificial manner. So it's basically maintaining a kind of the conditions that it would roughly have been even if this chamber were not there, the same pressure. And it just allows the methane to build up. And we use a stopwatch basically. When we put this over the leak, we start timing it and looking at the machine and recording the buildup of methane over time, and knowing the rate of buildup of methane over time and the volume underneath that shell, we can compute the grams of methane per time, per second or per hour that's coming in from that space. And so then we'll have to kind of replicate or do a transect along the street, and then we're gonna go along, you know, a strip of grass here and the park. And I think we should also then, you know, we need to talk about exactly what the best protocol is. Go to the manholes that are around and do those kind of spots that, you know.
What's your goal though? At the end game, what's your goal?
Grams of methane per hour from this leak. Or you could say cubic feet per day, you know, in the natural gas units, cubic feet per day per leak. And there's our friends at National Grid. What we're reading here is about 45 parts per million methane, which is about 22 times the background level. And that's what's in the chamber right now coming out of that pavement. And so, yeah, so we can zoom in on that portion here. 47.
There's holes right here.
That's good.
Okay.
So we'll put it over this hole.
Yeah,
You
that's
wanna use
pretty
the
strong there.
Yeah.
So, you know, you definitely want to start with this kind of flushed out to start off with. It doesn't matter if it's 5 or 6 ppm, which is elevated right now, because that's not even going to matter in terms of the linear buildup. So once you turn that on and put that kind of near that thing, okay? So this fan just makes sure that we have a mixed volume in there. And let's see, let's get a stopwatch going. Okay, so there we go. Start. Okay, so we're 5, 6, 15, 32, 39, 49, 67. So we're building up quite fast here. 66, 70. I think it's, no, why is it?
And the background parts per million is what?
Less than 2.
Less than 2. So low.
This thing's having some slight issues keeping up, I think.
Just so you've centered the leak, and then do the next one with a big piece of craft paper. But then you can get all your information here, you know, like.
So that's 9
This is
meters,
17
30
at
seconds.
18.
Yeah, 30 centimeters. Okay, great.
I don't even
Nine-
know what the day is. 9, 19, 13. We get a special survey. You get a grade 2 leak. Pine Grove
And grade 2 is information that you had prior, right?
You know, it was a grade 1 in front of my house at Creegor Drive. I wouldn't want to smell this all the time. It could still be the pathway, even though that's fixed.
Yeah.
This could be a pathway that's where the gas has been traditionally migrating and all that's very dry and hard. That's it, Zhao Zhang. Always let the bar do the work. Don't try to pull it with your back.
I think we need to have a much higher threshold than
Yep.
Well, this is a big leak. They're not always going to be like this at all. And you still haven't gone that way towards the other pole.
But this is where I think we need to use that Newton's method where we go out way farther than we think, and if there's a lower gas, then we work our way back in.
Yeah.
Because this is a long time.
We may need a longer prop because it's, for example, this is a grass area, right?
Yeah, but it'll
So it
still
doesn't
draw
go-
up to me.
Okay.
Even though it's short,
Uh-huh.
that hole goes in 6/8. It's drawing right from
Oh,
there. What
okay.
you want to do
Okay,
is
I
just
got
make
you.
sure that that's
Yeah.
tight to the top
Yeah.
of the ground. And look, there's the end. What, did you even get one?
0.6.
No.
Okay.
0.6 was the
So
highest.
that was the middle of the road. Now come back this way.
55.
So you're just going to
79.
keep going till you found out the
Yep.
extremities of the
Yeah.
leak. You think you'll stop at what? When it's
Well,
down to
initially
10%
we
or
had
5%?
agreed on 0.25% gas.
0.25.
So,
You'd
it
be
may take
walking
up
a long
to-
way.
Yep. We have constrained it.
Now you know where the
Found the
high
limits of
point
a very long leak here on Pine Grove.
Yeah, so we need to figure out what that threshold is. So it's obviously migrating some distance from the